Can't I go 5,000 transactions back, change the block that has given me 0.1 BTC and change it to 1 BTC? The problem is this, because in the blockchain, at least of Bitcoin, every block is dependent on the previous one, and in order for a miner to verify a block, he needs to find a hash with n leading zeros. So he is incrementing an integer over and over again until he says to the network, okay, I incremented this integer, and with the integer 2000, I was able to generate this hash with n leading zero. So everyone are now checking this and they say, yes, this is the correct solution. The integer should be 2000 because only with this integer you are able to generate this hash. Now this block is dependent on all the previous blocks, which means if you go back 5,000 block backs and you change one of the blocks, this would affect all the continuous solution, all the future solutions beyond these 5,000 blocks back, which means you would need to solve this problem or find a hash with n leading zeros for all the 5,000 forward, which is a very, very, very hard problem. So this is not done with today's computers, maybe only with future quantum computers. Basically, in the blockchain, we have a P2P network that holds the database. And if you want to join the blockchain, practically the first thing that you are going to do is to download the database to your local machine. So this already hints us that the blockchain is some kind of a distributed database that stores blocks. In each block, there is the transactions that happened. One person sent Bitcoin to another, a few transactions, and the header. The header has multiple parts. One of them is the solution, and a few of them are validations. The solution that you need to find is to find a hash with n leading zeros. We vary the nuance, the nonce, what's called, practically an integer. So if the nonce is 5, this means you need to find 5 leading zeros. If the nonce is 15, this means you need to find 15 leading zeros. So as we say that if we want a new block to be created every 10 minutes, then it's different if we have 10,000 machines trying to solve this problem or one machine. If we have 10,000 machines, we want the nonce to be higher, which means we want to find a hash with additional leading zeros such that the harder, and because the problem would be harder, and then statistically we would get the new block every 10 minutes, but we would get it only because that much many computers. If we had much fewer computers trying to solve this problem, then we can use the nonce, which is basically an integer like 3. And this means we need to find a hash with 3 leading zeros. So it would still take us 10 minutes to calculate the new block to find the hash that matches the solution to the problem for a new block. But it would take us 10 minutes because the nonce is smaller, and because the nonce is smaller, we have decremented it to a smaller value because we have that less many computers. Basically, in the blockchain, no one can stop both good and bad. There is no single. The fact that no one can take, then also no one can stop this transaction. The transaction with the higher fees would get higher priority over lower fees. Each block contains multiple transactions and then a header with the verification. The multiple transactions are there because of specific qualities. Those are just a bunch of recent transactions. But if you want your transaction higher, the faster, then this means you need to pay higher fees. There is some kind of an intermediary, a memory pool of transactioners are collecting transactions from there and trying to generate a block. Once a miner has generated a block with a successful hash, a hash that, remember, is dependent on all the previous blocks, so block, then he transmits it to other P2P, and all other miners are validating this block, and if they agree, then this block is added. So this was a very brief overview to the blockchain, especially the one that is used Bitcoin.